So my name is Sergei Sokolenko. I am a product manager at Snowflake, and today with me I have Felipe Hoffa. He's a developer advocate at Snowflake, and today we're going to do a quick presentation about Snowflake's geospatial capability, how we evolved into a geo data cloud. We were actually founded 10 years ago. This year we celebrated our 10th anniversary in August. Big party, awesome. Our mascot, the bear, was there. That was very positive. But when we came out of stealth in 2014, and a couple of years later, we were known to the market as a cloud data warehouse. We published a white paper, Snowflake Elastic Warehouse. We started, you would argue, we started the cloud data warehousing trend. But this year, since that time, we are now offering much more than just a data warehouse. We're offering a generic data processing platform that includes a data warehouse, and we also offer content, both data and applications. On the platform side, you can run your data science workloads, you can run your data engineering workloads, you can still do data warehousing really, really well. And we also offer a thing we call Unistore, which is a hybrid OLAP OLTP processing capability that's available in private preview now. So let's talk a little bit about platform and how it enables geospatial analytics. We have a geography data type. This data type is generally available, has been generally available for about 18 months. We offer 60-ish and plus functions, native functions. We also have optimizations for joins. Later in the talk, we're going to launch a new feature, a performance-oriented feature. For the things that we don't have or don't offer natively in the geography data type, you as a user, you're able to extend this capability through user-defined functions, UDFs. They can be in Python, they can be in Scala, they can be in Java. And all of these functions will run in their containers, and they will be processed really, really fast. And if you go even beyond, you can develop native data applications. So you probably wouldn't be able to develop a mobile game on Snowflake, but you can definitely develop something that crunches lots of data and has an output to a dashboard. We recently acquired a company called Streamlit. It gives you dashboarding capabilities, it gives you a nice visualization capability and data application capability. And we work closely with Carto. Earlier today, you heard from Javier about the data app that they developed together with us that is really, really cool for visualizing and analyzing, doing sophisticated analytics on data that is in your Snowflake warehouse. Now, this is an interesting graph. Who of you have seen it before? A few of you, right? It's supposed to represent the data sharing relationships between data suppliers and data consumers. We offer a marketplace. This marketplace has hundreds of location-aware data sets, so data sets that have a geography column in them on which you can join or search. And we have, of course, many thousands of data sets that are general kind of available, not specifically location-aware, but definitely more than 100 location-aware data sets. Some interesting parts of this graph show you some of these companies have hundreds of customers that consume their data sets. And the key point is you don't have to write any data pipelines to get data. So it's as easy to get a new data set as accessing a new schema. Now you might ask, what's going on with the dots on the edge of this graph? Why don't they have any connections, and why are you even putting them on this graph? Interestingly, there are companies that are sharing data within each other. And that's also a concept, because if you have a large company with multiple countries or maybe multiple departments, and they need to share data securely and in a governed way, then they're represented by the dots on these edges, on the edge of the circle here. They're sharing with each other. They're not sharing outside of the org, but they're sharing with each other, and they use the same mechanism for data sharing. All right, so what's new? Today we are launching two new capabilities. We're launching the public preview of the geometry data type. It's an addition to the geography data type that we've offered for a while. We are also launching fast GeoSearch. And let me talk a little bit about each of these two features. Why would you use geometry versus geography in Snowflake? Geometry allows you to be more flexible with your spatial reference systems. Our geography data type supports one SRS. It's the WGS84, the one that we love and cherish. But geometry actually allows you to use different spatial reference systems. In the preview form, we don't yet offer a transformation capability between SRSs. It will be added by the time we go into GA. But in the demo, I'm going to show you how you can convert between different SRSs with the geometry data type. Fast search. Fast search is very useful if you're trying to do bounded box or bounding box types of searches. So where you have maybe a viewport on the map, or you have a polygon that defines a shape of an object, and you're trying to search for other objects within that bounding box. We built a indexing capability. The search is really fast. Carto has built their dynamic tiling on this fast search capability, and they saw a reduction of query latency from tens of seconds to single seconds. All right, so at this point, I wanted to show you a demo. I'm going to go through a scenario of dynamic search pricing. Who of you have heard of search pricing? What it is? You're probably suffering from it every day, right, if you're taking ride-hailing app. Well, a colleague of mine, he actually used to work for one of the ride-hailing apps or ride-hailing companies. They're now really big companies. And he tells me that without this concept or without this search pricing, you probably wouldn't be able to, there wouldn't be a market for ride-hailing because the drivers would not be able to compensate it enough to support their livelihoods. So search pricing is a way for them to get paid a little bit more through high times of demand while they get paid less during normal times. So it creates a market. It creates the it creates the supply side of the market. When a ride-hailing provider is trying to predict or determine the right search multiplier, they typically are trying to calculate, should I increase my prices 1.2 times, 1.5, 2x, 3x? They look at inputs, market inputs. And these inputs typically are based on the flow of what's happening with a order in an application. If you remember what you usually do when you open Uber or Lyft, you enter a route from and where. The app will give you a quote. The quote will contain a price. It will already embed the search multiplier in it. And if you choose to accept that particular offer or quote, the system will book a request. It will create a request. It will send out to drivers. Now, when a driver decides to accept your request, it means a booking. The system will make a booking. And when the driver actually picks you up and delivers you to your destination, that's a completed ride. So that's the terminology of the business. Now, for our demo here, and to show you how you can build a dynamic search pricing system here, we picked the Chicago taxi rides dataset, which is publicly available. And of course, we divided the city of Chicago in geographic areas. We used H3 supplied by our dear partner Carto. And for each of these hexagons, what a typical provider would calculate would be how many quotes there were in a hexagon, how many requests, how many bookings, how many rides. And they also typically look at what drivers are available in a particular geographic area and what is the estimated time of arrival. And once you calculate these statistics, you end up with a map like this. For each hexagon, you have statistics on quotes, requests, and available drivers, and so on. Now, for our demo, we built a pipeline, and this would be a typical pipeline you would also build if you wanted to implement a search pricing algorithm. You probably have streaming data coming in, a Kafka pipeline, another streaming system. You can insert it through streaming ingestion into Snowflake and land it in a raw table with details about your rides. And then you would bucketize your raw data by hexagon and store it in some other tables. And your regular tables in Snowflake, compared to hybrid tables, which I will cover, your regular tables will serve two purposes. For example, you can build real-time business monitoring based on the statistics. For example, to detect anomalies. Secondly, you can use these tables, you can use that data to analyze it and use Carto to find, do you have an issue with your algorithms? Are there interesting behavioral difference between parts of town? Now, a recently launched capability that Snowflake now offers, hybrid tables can also enable machine learning by serving as the base for your feature store. So with hybrid tables, you get the best of two worlds. You get analytical power and speed. So if you have a large query that processes lots of data, you still get that speed of large analytical queries. But if you're trying to find records by key, individual records, you get that OLTP speed. So you get very, very fast speed of access to records. And you can use it for feature stores, retraining models, doing predictions. All right, so enough slides. I'm going to switch to demo. In this demo, and at some point, Felipe, my colleague, will join me as well, we are going to show you, try to answer a couple of questions. One of the questions will be, well, I have my statistics on hexagons. I know how many drivers I have. I know how many requests and bookings I have. But can I enrich my information about areas with some external data? So get data from Marketplace. I'll show you how. Another interesting question to ask is there any weirdness in my data or in my algorithms? Can I see, for example, areas of high demand but very low completion rates? A completion rate is how many actual rides happened divided by the number of requests. At this point, can we switch to my laptop, please? So here I have the Snowflake editor. That's the typical interface for me to write my scripts and statements. Initially, I'm going to run a couple of setup commands. I'm going to use a warehouse. In Snowflake's terminology, a warehouse stands for a processing cluster. This is my compute. I'm going to access a database. A database, again, in Snowflake's terminology, is my data. And data and compute is separated, so I can use different warehouses accessing different databases. Or actually, I can have multiple warehouses accessing the same database. And all of my data is in this Chicago taxi schema. Let me just show you what I have inside. My streaming pipeline keeps pumping data into the rides table. That's this one. And to give you a feeling of the data inside, I have my timestamps of when a request was made. I have the fare information. So this is a completed ride, a ride that was actually a driver did drive a person to the destination. And some of the most important data points are, of course, the pickup point. And it's a geography object. So it's a location. And the drop-off point. Well, great. Now, remember, we wanted to aggregate our raw data and calculate statistics by hexagons. And today in Snowflake, you can do this by using Carto's analytical toolbox. I'm going to use the h3 from a point function to calculate my hexagon IDs. Let me show you how it works. Eventually, we're going to end up with a table, a much smaller table because it's statistics. With the beginning of the time bucket, the H3 ID, and the number of requests, the number of rides, the average price in that hexagon. Now, for those of you who paid attention, I mentioned that I wanted to enrich this information with some additional statistics about the area where the pickup is happening. Specifically, I wanted to calculate how many restaurants are in a particular hexagon, because I have a hunch that the number of entertainment options, number of restaurants, might influence the demand in a particular area. Now, how do I get external data? In Snowflake, this is as easy as referencing a different schema. We have these hundreds of data sets available in Snowflake, and we have the OpenStreetMap data set for United States and many other geographies. Actually, I think pretty much every geography is covered. And they offer many, many views. And let me show you where it all is. And one of these views is amenities. A long, long list of different views, different point of interest information. So I'll be looking for restaurants, and that's what the query does here. I'm going to run the entire query. And I'm going to join my driver information, my taxi rides information with the information about restaurants. And I'm going to use the H3 indexes to join them together. All right, so it's calculating the stats. Should not be surprising to you. I have my time bucket. I have my H3 hexagon ID, and I have still the number of requests, rides, average cost, and now, amazingly, we have the number of restaurants in that bucket as well. And I can continue extending my data set with other external data if I wished. Now, let me show you one more feature before I transition to Felipe, and he's going to give you a demo of Carto's analytics. What if I wanted to extend Snowflake's capability with some Python code? That I wrote. Specifically, I wanted to convert from one spatial reference system to another spatial reference system. Snowflake offers you Snowpark. Snowpark is an execution environment for user-defined functions. We support Python, Scala, Java, and other languages. And this particular function is accessing Shapely to do the conversion between one SRS to another. I'm going to run it here just to deploy it to my backend. It's fully serverless, so you don't really need to care where it runs, host ID, host name. You don't have to worry about it. Using these new functions that you define is as easy as referencing them in your SQL statement. So that's this function that I just ran or created. Then I can use the power of SQL to convert from one SRS to another. What this statement does, it will convert all the coordinates of pickup points from the initial spatial reference system, which is WGS84, to a Illinois-specific spatial reference system. It's Illinois State Plane East. And here are your coordinates. All right. Hopefully this was useful. It showed you a couple of things, how you can define extensions, how you can do hexagon analysis. At this point, I would like to invite Felipe, and he's going to do a demo of Carto and Snowflake.
Hello, I'm back. Yay. Thank you, Sergei. Here is Sergei. Can you hear me? Is the microphone working? Yes. So I'm Felipe Hoffa. I'm super happy to be here, super happy to work with Sergei. You may know that I used to work for Google like for 10 years. I used to work with Sergei at Google too, but now I've been working for Snowflake for the last 2 years, and I'm happier now. I'm happier, that's how I feel. Anyways, my job is today is to show you a demo of Snowflake working with Carto, so let's do that. I have the data that Sergei prepared for me. So he went through all these steps. I love that he was able to run Python inside the Snowflake. Here you can see the pre-aggregated writes by H3 block, the number of requests writes every 15 minutes. This table has around 15 million rows. And let me visualize that in Carto. So this is Carto Builder. Hopefully you all know it, but if you don't know it, this is my demo of it. Let me grow this window a little so I can get the new query. And I'm going to just paste my query here from that goes to Snowflake, retrieves 50 million rows. It's a little scary because, of course, you don't want to move 15 million rows around, but it will run, yeah, and it runs really fast. Carto is already visualizing it. Let me close the query. Here we are. And this is part of the secret of what Carto does, which is, if I go to look at my query history of the queries that have run in Snowflake, that simple query, select star, it should show up here now. It was run by Carto. Let me look at what query was run. Yes, this is my select star, but Carto is hiding this query inside a subselect that is doing a lot of pre-aggregation and looking at the viewport and making sure that we are not moving 15 million rows, but we're just moving the rows that we need to look to visualize. So at the end, we only got 120 rows into Carto, and I love how they do that transparently. So let me go back to what a data scientist at Uber or a different ride-hailing app would do. This is the demo that our teammate wrote, that he used to work at one of these companies, so this is how a data scientist there would work. Here we have a chart of requests during certain time frame this day, and we can see a peak here. And the data scientist at the ride-hailing app job is to see if this was a real source of a peak or if we have problems collecting this data. Sometimes data comes out in the wrong way and it's not a real life problem, but it just comes out wrong from all of our processes. So what he would do is he looks at this peak and then he goes deeper to see what's happening at this particular hour. And here in Snowflake, I get this little visualizer, but I cannot look at things in a map, so I can just copy my query to Carto. Let me do that, and I want to go quick so we have time for questions. Because I love questions, I'm going to take the query here. I'm going to copy my query, looking at the writes that were happening at that particular time. Let's look at the style. I'm going to visualize you. I don't need you. Not the color, but that we're going to fill depending on the number of requests at that hour, average. And Carto is doing its job. And we can see that at that particular time, there were way more requests from Chicago downtown. So my teammate, the data scientist, is like, this looks fine. If we look at a different time that had also a similar peak, and this peak happened at this time, and he's like, is this a real peak or not? And a great way to look at this is visualize again, and this is the query that he would use. And hello, Carto, let me change the query here, run. And again, Snowflake working together with Carto. You can see that here, this time, every H3 hexagon is giving was showing the same number of requests, so it's like, it's suspicious. This is not a real peak. And that's how the data scientists at his company used to look at these kind of problems. And the last query I have to show here is going back to the peak time search pricing. So let's look at writes at certain particular, during the morning in Chicago. I'm going to copy this query to Carto again. And now I want to look at the difference in the number of requests versus the number of trips completed. So here we're visualizing the number of requests. There's a lot of requests at this time in downtown. And I'm going to duplicate this layer. I have a copy. I have a dual map view. I'm going to style my copy here. And instead of looking at the number of requests, I'm going to look at the number of completions. And the zones with more requests should have more trips completion. And if it's not that way, then we are underserving that area. And this is, let's show one layer on this side Let's show the other layer on this side. And you can see here that there are a lot of requests in downtown, but there's not a lot of trips complete. And these are taxis, so they don't have surge pricing. And with surge pricing, we can solve this kind of problem because we would motivate taxi drivers to come back to the city. And that was a demo I had prepared. I have Sergei back here. We love having new friends. We love questions. You can follow us on Twitter. You can follow us on LinkedIn, Reddit, Stack Overflow, and wherever you want to find us.